Where the event happened, user acceptance testing. Okay? Our users told us at the beginning of this, we need 8 months to test this thing. And we said, you are crazy. They were. They needed 13 months. That timeline is real. We tested the heck out of this thing. Probably, in my 15 years in GE, the most detailed test plan for a single system that I have ever seen. Sure.
Why did it take 13 months? Because did you have test plans going into the project, or was something involved?
We did. I think a lot of it came back to that skeptical nature. You know, when I say here we created 4,800 test scripts and ran them multiple times, we ran through them all, everything worked, and they go, I don't believe it, we're going to do it again. And so there were, I mean, 3, 4, 5 rounds of this testing. And it wasn't easy. I mean, you see, we had 303 business users testing, and at the same time, they got to make money for us, right? They got to service their customers. So I think it wasn't 13 months of testing effort. It was probably more of an elapsed time because people, you know, we didn't have a professional testing organization. These are the super users that are running a test script and in the middle picking up a call to service a customer and then coming back and trying to pick up where they were again. So it was a lot of testing. It was a lot of people. The defects weren't outrageous. I mean, the pie chart kind of breaks it down. It's exactly what I expected. Half the defects are in the online and the batch. The other half were performance, environmental, things like that. No showstoppers, obviously. But, you know, that's why you test. You got to find those defects and flush them out. You're changing your code. You're converting it. In a rehost, I think this would have been a lot less because it's a lift and shift, right? But we literally changed our code base. Okay. So this is the tickets open per month. And the reason I'm showing you this is probably one of the mistakes we almost made. What I'm going to focus on is the 2 implementation periods that we had. The first one for our direct business, the second one for our indirect business. We were originally, everything's going live at once, right? Which everybody goes, wow, why would you do that, right? Nobody does that. Well, these systems, we have a direct and an indirect, but back in 1987, they were one system, one business. The business is split. They each took a copy of PMS, and the direct side, who leases aircrafts, right, high dollar, low volume, do things one way. Our indirect business that leases copy machines, right, low dollar, high volume, have 2 completely different ways of doing things now. So those systems still shared some code, and we did not want to try to untangle that, run one on the mainframe, and run one on Unix. However, we did decide to split them, and probably one of the best decisions we made during this project. And the reason I'm telling you that is, here's a blow-up of those tickets. The first implementation versus the second implementation. Keep in mind, the second implementation, the indirect side of our system, is 10 times bigger than the direct side. And we had probably more than half, less than half the number of tickets or defects open during that user acceptance testing. So one of my lessons learned that I want to share is, right, and you'll see it later, don't try to do everything at once. It sounds very, you know, straightforward, of course. But the knowledge we got from that first implementation from a technical standpoint was huge. And not only that, our user base went, okay, this really does work. They had months to be in the application on the direct side before we went with the indirect side. So in hindsight, one of the best things we ever did. Is there a question?
Yeah. Was there any interfaces between these 2
No, there was no data that was being shared. There were copies of the same programs. There were interfacing systems that would send data in or pull data out, and we would consolidate stuff before it went out and put an identifier on it. Right, this is direct, this is indirect, that kind of stuff. So there was no functionality tied together. The business would tell you that they're 2 completely independent systems. But behind the scenes, there's still some strands of the spider web left. And we really didn't want to undo that, but we did. And we were successful. It probably added a month to our project to make sure we did that right. But in the end, I mean, it really paid off. Okay? So the moral of the story here is don't underestimate that user testing phase. It was a humongous effort. They did a fantastic job both on the IT side and the business side, but it is big.
I have one more question.
Sure.
You didn't talk about performance. So.
Come on. I owe you a drink. I'm going to have to take out that credit card tonight. So, performance testing. my favorite part of the project.
I saw your presentation.
My performance testing was actually my favorite part of this project. Why? Because it was the biggest problem we had, and therefore it was the most amazing thing to crack, right? Because we did it. So GE, as a standard architecture for applications, wants two-tier architecture, right? From a disaster standpoint, app tiers, active-active, database active-passive, connection between the two. So we started out with that. We bought 8 Sun M5000s because we decided that our non-production and our DR could live in the same environment. In a disaster, we would shrink non-production to almost nothing, and we would run PMS on the non-prod boxes. So we wanted the same architecture. In GE, those are in 2 different data centers. Obviously, from a DR perspective, they would need to be. But what we found is we were unable to get the mainframe performance. Remember, our requirement was same as or better than the mainframe, or we're changing the usability of the application, and therefore we're not going. Okay? Cindy and KJ heard that every day 1,000 times. Same or better, same or better. Okay? So what was wrong with the application, right? Why didn't that work? And basically what we found out is our PMS application, IDMS, was built to run on the mainframe. It's not built to run in Unix. It's very, very chatty. And not to get too technical, and if people have questions after Cindy or I or KJ, I'd be happy to talk about it. What we found was, because we were in a 2-tier architecture, every call we made from the app to the database had overhead. TCP/IP overhead out of the app into the database, out of the database back to the app. No big deal. It was milliseconds. However, one transaction has 8 million of those. 8 million calls. So 8 million times 1 millisecond is a really slow application. Okay? So it wasn't OpenFrame that was slow. It wasn't the way we converted it. It was you're trying to retrofit something that was built for one thing and now use it somewhere else. So, like I said, we had a high number of database calls in the application and a high number of programs executed by a single transaction. Right? We spawned stuff over and over and over again. So what did we do? Basically, our final architecture became a single-tier architecture, and the reason we did that was we took the TCP/IP overhead out of the way. We're now riding the backplane of that box. It's a big box, right? It's a Sun M9000. I think we can probably run NASA on those things, right? Now, we could have gone with 8,000s, but we would have been at the top of the configuration, and we still have mainframe apps left in GE Capital, so I went with the base 9,000 versus the top of the line 8,000. So we had basically infinite scalability. In our new environment, we're running 16 quad-core CPUs. We're also not active-active anymore. We're active-passive on those boxes. So 16 quad-core CPUs. So across the 4, there's 128 cores running there. Right? These boxes can go to 256, and then you can double them. You can put 2 in one chassis. So really, we have infinite scalability. It wasn't that much more, so that's why we decided to go that way.
What's the utilization on cores? Like, there's tons of juice here.
There is. And what we found, I don't want to give away, again, the punchline, but no, actually, you're going to buy him the drink now. You're making me go out of order. Basically, what we found with everything on there right now in the 9,000s, we're at about 10% utilization, which is fantastic. Again, with 16 CPUs, let alone the 64 you can throw in there or whatever it is. Okay. We finally achieved mainframe comparability, right? And this is the coolest part. You'll like this. Here is real data. This is an entire stream that represents our Cheetah application, and it doesn't really matter what the tasks are because it won't mean much to you guys. But here is the mainframe baseline that we were trying to reach. And up and down the side here you have transactions in seconds, right? The time it takes to run that transaction. Lofty scale, right? That's mainframe performance, almost sub-second. So on the two-tier platform, this is what we had. We are in trouble, right? It was ugly. It was really ugly. And again, the main reason, that TCP/IP overhead times 8 million calls in one transaction. Okay? The great news, going to the single tier, awesome. Right? So I put the slide in again just to kind of show it a little more zoomed in, right? So our scale, same data, but our scale is now not to 10, it's to 3.5. I took out the bad one. So here's our mainframe baseline. And remember, better or sub-second is what our goal was. There's that transaction. It was awesome, right? And all those guys in the architecture group that said, you're never going to get that performance. Haha. We got it. It was awesome, right? I love telling them that. Okay? So really, really good. Basically 100% faster or sub-second. There's not a single transaction that is greater than a second now on these 9000s. Not only that, I think the dot over at the end there, the highest one, is like 0.6 seconds. I mean, it's not even close to a second. Again, this is just representative of one stream. Oh, one other thing I can add to make it even a little better. The mainframe test here was 1,100 concurrent users. The OpenFrame single-tier test was 1,400 users. So it was actually even more users that we compared. So, okay. Performance testing.
So, can you go back to the previous slide?
Sure.
Yeah, because no, actually previous to the whole architecture. Yeah, right there. So this is the DR that you.
Yeah. So we kept the prod non-prod, right? Same as DR is in the non-prod environment. So we replicated the exact same storage. So we bought 4 M9000s. Okay. Any other questions on that, the performance testing? You get to see this cool graph again. Cindy and I like this graph.